Okay, so this question in 2 dimensions has a lot going on. This is actually question 4. I don't know why it says 1. There's a lot going on in this question. There's forces up, down, to the left, at some random 40-degree angle to the right. So we got to figure out what to do. And this is pretty typical. And what we're going to do when we encounter problems like this is to basically break things up into the vertical. So we're going to break up the vertical and the horizontal. Okay, and what we're going to do is we're going to calculate F net in the y direction and F net in the x direction. And in the y direction, it's the sum of the forces in the y direction, right? So up and down, y direction. And then in the F net x is the sum of the forces in the x direction. So left and right. All right, so that's what we're going to do. We're going to break everything up. So some of these are very clear. It's very clear that, for example, 34 newtons is up. It's the normal force. The force of gravity, I hope you remember that whenever you see Fg, you can always make it mg. And if you know the m, which we do, in this case it's 10 kilograms, you can calculate the number. So we've got 10 kilograms times 9.8 meters per second squared, which gives me 98 newtons. So my force of gravity, the value there is 98 newtons, and it's pointed down. I've got a force of friction pointing to the left along, because presumably this person is pulling their rollerblade, and they're actually moving in the horizontal direction. But when you pull a roller bag, you apply the force at sort of an angle. And the way that it's described in this problem, the angle is 40 degrees above the horizontal. So what I want you to notice here is that you're going to have, which color code am I using? So what we're going to have in this case is an x component of the applied force and a y component of the applied force. Okay, so this is F A in the y direction, and this orange vector is F A in the x direction. Now we know all those numbers, we can calculate them. So let's just calculate them. F A in the x direction is simply equal to 100 cosine of 40 degrees. And that equals 76.6. Let's just call it, 76.6 newtons. And then F A in the y direction is just 100 sine of 40. And that just equals 64. I'll round to 64 newtons for the sake of simplicity. All right, so I know that. Now let's add everything up in the x and the y direction. So let's say F net in the y direction. Now if I look at my diagram and I choose my sign convention, so what I can do is pick a sign convention so that up is positive, down is negative, right is positive, left is negative. These are your conventional Cartesian positive, negative directions, right? So if I'm looking at the vertical, so this is in the vertical direction. In the vertical direction, I've got the normal force. So I've got the normal force, which is pointed upwards. I've got the force of gravity, which is pointed downwards, so minus Fg. And then I've got this Fay pointed upward. So I'm going to say plus Fa in the y direction, the y component of the applied force. So these are the three forces acting in the vertical. So I've got 34 newtons, 34 newtons minus 98 newtons plus, and this one is 64 newtons. And if you notice, that adds to 0. We're going to talk more about that, why that should be the case. But right now, that's how the math worked out. Okay, and then we can check this out in the horizontal. In the horizontal direction, we're going to find F net x, and it's going to equal, now what are the forces acting horizontally? Well, we've got Fa x in the positive x direction, and we've got minus the force of friction, which is working in the negative x direction. So plugging in the numbers we have for this, we have 76.6 newtons minus 25 newtons. We end up with, what does that work out to? 76.6 minus 25 equals 51.6. So that becomes my net force net force in the x direction. F, what am I writing here? F net x. Okay, so then what we want really is F net, is the resultant. But since the vertical is 0, then my F net, it's the triangle, right? But in this case, the triangle, the y component is 0. So F net is just going to equal 51.6 newtons. And you could say to the right because it's pointed directly to the right. All right, so try the other ones on your own, see if they make sense, and then bring all your questions to class the next day. Okay? Good luck.